The focus of this lesson is right triangle trigonometry. So we're going to start by reviewing our trig ratios for sine, cosine, and tangent. The sine of an angle is equivalent to the ratio of its opposite leg to its hypotenuse. Cosine is the ratio of its adjacent leg to its hypotenuse, and tangent of an angle is the ratio of its opposite leg to its adjacent leg. So in referring to angle A, opposite angle A is side A. Adjacent, which means next to angle A is side B. And then we have our hypotenuse, which is always opposite the right angle. So what's important to remember is that opposite and adjacent change based on which angle you're referring to. So if I was referring to angle B, opposite angle B would be side B, and adjacent to angle B would be side A. So let's look at an example. Let's say we have this side X, and side Y, and side Z. We're going to call this angle B. So if we wanted to find the sine of angle B, that would be equivalent to the ratio of its opposite side, which is Y, over hypotenuse, which is Z. Cosine of B would be equivalent to the ratio of its adjacent side. So adjacent to B means next to is X, and hypotenuse is still Z. And tangent of B is the ratio of its opposite side. So opposite B is side Y to its adjacent side, X. So if we had this triangle here, and we wanted to solve for cosine of A, that would be equivalent to its adjacent side over its hypotenuse. If we wanted to solve for the sine of A, that would be equivalent to its opposite side over hypotenuse. Now, if we actually wanted to get the value of this angle, we would need to use something called our inverse trig function. And we can use our calculators for that. So inverse on a calculator is a superscript of -1. So if we take the inverse cosine of 4/5, or the inverse sine of 3/5, that would give us the value of this angle. So let's look at this example where we use our trig functions to help us solve for this angle here. So it says two boats are traveling toward a lighthouse that is 200 feet above sea level. At its top, when two boats and the lighthouse are collinear, the boats are exactly 250 feet apart, and the boat closest to the lighthouse has an angle of elevation to the top of the lighthouse of 15 degrees as shown. So what is the value of X rounded to the nearest hundredth? So what we need to know is the length of this entire side so that we can solve for this angle here, because you can see that creates a right triangle. So let's start by solving for this value of X. So we're looking for, well, actually let's call this Y. So we're going to solve for this value of Y. So you can see our right angle. So the first thing we have to figure out is which of our trig functions do we need to be able to solve for this. So reminder, sine of theta, or any angle, is equal to the ratio of its opposite side to its hypotenuse. Cosine is equal to the ratio of its opposite side to its adjacent side. And tangent of an angle is equal to the ratio of its opposite side to its adjacent side. So start by looking at what information that we are given. So 15 degrees, we have the side opposite the angle. So we know we have opposite, so we're going to want... All right, let me correct that real quick. So cosine of theta is not equal to opposite over adjacent. Cosine of theta is equal to adjacent side over its hypotenuse. Okay, so that makes a little more sense. And we are looking for y, which is adjacent to 15. So opposite is what we have. We are looking for adjacent, so we know that we want to use our tangent trig function. So let me erase that out. So we're using tangent. So tangent of 15 degrees is equal to opposite, so 200 over y. So now we want to solve this equation for y. So I'm going to multiply both sides by y and divide by the tangent of 15. So y is equal to 200 divided by the tangent of 15. So let's go ahead and evaluate that. And that gives us 746.55. So this value of y here is 746.55. So the length of this entire side of the triangle would be 746 and 55 plus 250, which is 996.55. And again, that's rounded to the nearest hundredth. But that's not what the question asks us for. The question asks us to solve for this angle x. So let's go ahead and do that. So we're solving for this angle. We have opposite and we have adjacent. So we're still using tangent. So tangent of x degrees is equal to 200 over 996.55. So this time we are solving for an angle. Anytime you're solving for an angle, you use your inverse trig function. So we're going to evaluate the inverse tangent of 200 over 996.55. And that gives us 11.35 or 11 35 of a degree. So that gives us our value for angle x there. So in this question, we're evaluating complementary angles. A and B are complementary because we know that the sum of all the angles of a triangle is equal to 180 degrees. So we know that A plus angle B plus angle C has to equal 180. And we already know that angle C is a right angle. So therefore we know angle A plus angle B has to equal 90. So they are complements of one another. So let's evaluate our trig functions of complementary angles. So cosine of A, so if this is angle A, this has to be 90 minus angle A. Cosine of 90 minus angle A. So cosine of A is equal to, let me just put in values here. Cosine of A is equal to the ratio of its adjacent side to its hypotenuse. Cosine of 90 minus A, or same as saying cosine of B, is equal to adjacent over hypotenuse, A over C. The sine of A, sine of angle A, is equal to the ratio of its opposite side to its hypotenuse, A over C. And the cosine, the sine of 90 minus A, oops, let's go ahead and rewrite that again. So sine of A is equal to opposite over hypotenuse. Sine of 90 minus A, also angle B, is equal to B over C. And that was equivalent to A over C there. So you can see by this there is a relationship between complementary angles. The cosine of A is equivalent to the sine of B. And the cosine of B is equivalent to the sine of A. So in this question, which statement must be true? Cosine of A is equal to the sine of B. True.